mass was the rocks after 15 minutes of drinking, which was 77.3.
Okay, so it's 77, okay. So I'm gonna write that over here.
77 and 3/10.
All right, and Tanya, what was the highest mass that you measured?
Well, the beginning mass, which was 100.
No, of everything.
Oh, sorry.
Everything.
413 and 5/10 grams.
Okay, so I'm gonna say 450, just so round. So are we gonna be able to get that with the sensitivity that we want on one graph?
I just gave you the rocks.
That's fine. Yeah.
No.
So can we measure 77 and then 77.2? I mean, can we get those little minute changes in there effectively? When our scale goes from 77 to 415?
No.
So we probably need to break this into two graphs. So I'm going to leave this one as my title. What should I do first? The mass of the rocks or the mass of the total? Okay, the mass of the rocks.
I figured it'd be easy.
Okay, so Tanya, you told me your low was 77. What was your high? 100, is that what you said? Okay, so we can still do our scale break, can't we?
Right.
Okay.
Not because we're stuck in sixth
So
grade.
let's say 75 here. Does anybody have anything lower than 75? 70? Okay.
No, because
And then we're going up to 100. So let's see.
We did 15 straight minutes.
That's what we were doing, yeah. We were not the only one.
All right, so group super duper over here has given me their data. So I'm going to take a moment to plot the mass of my rocks over time in our first graph. So y'all go ahead and do that for your data as well.
So it's 0.
So in conclusion, the math.
Oh, we want to go over Is this continuous? Yeah. Did you choose that right one? We're going to have some missing data.
Okay, so at 3,
Became less. Decrease, that's the word I was looking for, thank you. Decrease. For the most part.
what you read?
Mostly.
At least they're not big. My kids are saying 91 is 5.
Oh, I didn't.
Until like that, it may be like.
I'm gonna do a speculation, so this is what we anticipate to happen, and then we continue. So if we did it after 15, so it would be,
Oh, no, it's okay. I should have copied it down.
and it would be, so the predicted values, I'm gonna predict 96. We had 96.
96.
Yes, ma'am.
He Googled it and it said the squiggly.
The squiggly?
What's the name of that?
It's called
You're kidding me.
That sounds a very technical name.
It's
It's called a swimming. Oh no, we should put expected, we could put hypothesis.
Okay, then after you create your first draft,
Done.
okay, well, we were, Martin plotted his data on one graph using 2 scale breaks. So I want to show you this.
As your teacher's talking.
Okay, Martin, great job on this, by the way. This is great. So Martin has a scale break down here and another scale break between the greatest mass of the rocks and the lowest mass of the rocks, water, and jar together. So he can compare the shapes of his graphs on the same graph. You can do that either way. It's fine, but this is one way that Martin came up with to do it. It looks good. Thank you very much. You did it. You did it. Okay, now, let's do our analysis. What relationship do you see to this between these 2 sets of data? The mass of the rocks and the mass of the total. The rocks, the jar, and the water together. What is the relationship?
They are,
What did both of them do? Or what did they not do? They both decreased in mass. Okay, why do you think the mass of the total decreased?
We lost water from between blotting to the sifter, maybe the sediment in the sifter. So when it all went back in the jar, we didn't have what we started with.
So our system lost some mass
From the
by
water.
human error, or just by the process of removing it. Okay, what about the mass of the rocks? Why do you think the mass of the rock chunks was lost, Martin?
Some of that transferred to the water through weathering.
Okay, so how did it do that?
The lighter or smaller sediments that may be coating the rock, and sand and clay, whatever small particles, was being rubbed off as we were swirling it in the water.
Okay,
And then-
so the rocks maybe had some dirt on it, and this served to wash it away? Okay, so do you think it took 15 minutes to do that? Or do you think the first trial would have taken care of that dirt?
I think the first trial got certain off, but then doing it the second time, the water would have some sediments in it, so those sediments might actually increase or accelerate
Okay.
the weathering because they're more abrasion would be going on. So
Okay.
as it got more and more murky or more full of sediments, it probably would weather even further.
Okay, thank you. Yes.
I guess according to our data, that first rinse took off the most. Yes, there was still slightly, decreasing from the abrasion or the other sediments, but that first rinse, according to our data, took off the most. There's the most difference in the weight.
Okay, and I love that you're referring back to your data. That's great. Okay, so let's talk about why all this happened and connect it to what we've learned. Sort of. Okay, now we're going to go back to your handout, I believe, and it says, it's the second page. It says, what part of this investigation modeled weathering? So when you were running through all these ambiguous steps, what part of this modeled weathering out, natural weathering?
When we were shaking and swirling the rocks, that was the weathering. That was when the rocks were being acted upon that caused them to weather, to break apart.
Okay, so weathering is?
the
What-
breaking down of rocks
Weathering is the breaking down of rocks.
by wind,
So,
water, and everything. So
Okay.
that was the water.
It was breaking down.
okay, so water was breaking down the rocks. Agatha,
Yes, ma'am.
when you were going through your procedures, which one of these modeled erosion?
Yes.
The erosion, the part of the process of model erosion was the rocks against each other, the shaking of the rocks against each other, and also the sediments that are moved by the water.
Okay, so Elizabeth, can you help me out with that? Can you elaborate a little bit?
I've also included as part of erosion, taking the rocks out of, instead of erosion, correct?
Mm-hmm.
Taking the rocks out of the container and moving them around, transferring them to the balance on the table and back in the jar.
Okay, so I heard Agatha say that within that system of the jar, when you were weathering the rocks by shaking them, you were also sort of transporting some of those sediments a little bit. And then you said when you poured it out, that was modeling the erosion of the sediments out of the jar. Okay, great. Anybody have anything to add to that? Any more erosion you see? Okay, Maura, would you please share with us where you saw deposition in your system, in your lab?
When we poured the water out of the, and everything into the sifter, you had deposits at the bottom, and we would shake them out of the jar. Each time you got more stuff left on the sides of the jar, I suppose.
Uh-huh. Okay. Was there any other time during your procedure that you saw that, Shayna?
Deposition, other than
Yes.
just what was left at the bottom. With like the actual large rocks that were just settled at the bottom. And then
Oh, that's good.
other than that, like once we left our jar sitting for a while, we noticed there was a really thick deposit of like fine sediment.
Okay.
So that was really interesting, on the sides and at the very bottom.
Nice, thank you.
And paper towel.
Yeah.
You saw some of the paper towels.
Because it was colored,
You,
so you would think that, yeah, some of that water mixture.
so it wasn't the literal dumping of the rocks onto the paper towel?
No, it was what was left
Could
on.
be
Yeah.
deposition, could be
Yeah.
deposited rocks onto the
Well,
towel.
but then it was off of the napkin, so.
Okay, all right, cool.
Well,
Thank
but
you.
also on the sifter, as we continued to do it, you could see deposits of, deposition within the sifter. I mean, it started getting dirty where, like the jar did. It was around in the bottom of the sifter as well.
Okay.
You couldn't get all that out.
So if we took your jar that we've already taken, and you shake, say you shook for 3 hours,
Right, you may have gotten somebody else.
and then you let it sit still, what do you anticipate that jar is gonna look like if you come back in a week?
Layer. The sediment's gonna be, if not still floating on the top, maybe sunk down back to the bottom. Like when we did the jerk thingies.
The sediment tube?
Yes.
Yes,
It was all on
yeah.
the top for a while and murky, and after some time you could watch it, the little rings slowly move down and
So what pieces will have filtered down first?
the more dense.
The heavier, the bigger pieces, the more dense pieces will have come out of the suspension first.
Okay, wait just a minute. This is all from the Earth's crust, all the limestone. Does more mass of a piece of limestone change the density of a little piece of limestone?
No.
So it's just more massive. And
The
so it's
larger
gonna,
particles.
that's right, and they're not a density difference.
No.
Okay, because it's all the same substance.
Exactly, the density would stay the same.
Okay.
I thought I heard you say,
Yes, you did.
Okay.
Okay, and then Brenda. Where are you, Brenda? Brenda, based on your data, what can you say about time as a factor in changes in the geosphere?
I noticed that as time on my graph passed, the amount of mass that we were weighing that was left decreased. So that means over time, as you have deposition, taking stuff away, what's left over.
Okay, what do you have taken away?
The other pieces, sediment,
Okay,
So this is weathering, what was weathered
yes.
is eroded. So then what's left at the original, the origin that you began will be less because that mass has been removed to another location.
Okay, so was mass conserved in our experiment? Was the mass of the rocks conserved?
It's still there, it's just not at that location, it's in another location.
Exactly.
So you still have the same mass, the mass wasn't destroyed, it was just relocated.
Okay, good. So some of it's left on your paper towels.
Yes.
Some of it's left in your sifters. Some of it's clung to the sides of your jars. But the mass is still there. The
Yes.
mass of the rock is still
Exists,
there.
just a
It's
different
just
location.
in teeny tiny little pieces in suspension so you can't sift it.
Or a different location.
Yes. So these sifters, guys, we chose a very coarse sifter. So what would have happened if we had a very fine sifter?
It would have stayed with
Would have
the
more
rocks.
What if?
You could have done.
Our original mass should be very close to.
Than the
We wouldn't have as
original.
much loss.
Yes, so we would have, our mass would have stayed closer to the original because we're keeping smaller and smaller particles. Okay, last question. Tim, you ready?
Sure.
What does the before and after mass of the jar, rocks, and water tell us?
Before and after the mass of the jar, rocks, and water tells us that over time, weathering, erosion, and deposition will cause the mass of an object to become less.
Well, the mass becomes
Or it moves.
Okay. Okay.
And then, because we missed weighing everything together at 2 points, so.
But that's okay, because you got the beginning and the end, right?
Yes.
That's a
Yes.
big picture.
And it was-
Okay, and I'm curious, I know that some of y'all did 5 trials, some of y'all just did the whole thing. How did the mass, the ending mass of your jar, water, and rocks compare to the beginning mass? Did y'all have as much of a loss as the rest of us did? Yeah,
In your water or in your rock?
You would think you wouldn't.
not the rocks.
Combined of all.
That wasn't all.
Yeah, I'm wondering how the water loss, y'all's water loss compares to
Our
our water
beginning, like our first water jar rock day before shaking was 413 grams. And then after 15 minutes of continuous shaking, when we re-raised the jar, the water and the rocks together again, was 178. So 35 grams.
How does that compare?
We only lost 30 grams. With the
You didn't even lose that much, yeah.
We had so much sediment. Yeah, there was a ton of sediment in the
Oh, that's a good point. So yours wasn't as much water loss as it was a sediment loss.
We were trying to shake it again and it wasn't.
Okay.
So we just rinsed it to kind of rinse all the
How do you
pieces that went through
think,
that.
Donna, how do you think we could improve this investigation were we to do it another time? I mean, how do you think we could redo this and make it better so that there was not as much of a mass loss with water and
I
sediment?
think that would have.
I'm thinking, that's why I'm not answering quite yet, because I'm trying to process it. I don't know, because, I mean, if they
You wouldn't lose so much.
shook it for the full 15 minutes, I mean, I think breaking every 3 minutes, because we lost, our loss of mass of all 3 was less than theirs. So I think that the breaking every 3 minutes, for some reason,
Yeah, because you're blocked. Yeah, but your loss is probably more of the water, because when you
Right,
were
so
in
you only-
the house, so you lost water.
We only lost 3 grams, almost 4 on the
But
rocks.
what if we had, go ahead, Mark.
I say, what if the container that you were using to shake had a sifter in it? So that you weren't having to move it and shift it between the two. You kept the rock in the shifting area, so you're shaking it, you get the swirling, but it still all drops, and you still keep the rocks.
Like a steamer thing for your
Yeah.
vegetables.
But would the sifter add to, I guess it's probably the point, to the abrasion?
Yes.
Is that, would we want that?
Would that help prove a point?
Yes.
I mean, does it,
Still
Well,
be
that's
the same.
external courses.
Maybe not
For
water.
this, we only had rocks and water.
Yeah, but that could be symbolic of like tree branches in a root or something that was made.
Use cheesecloth.
Maybe not plotting them
There
or
you go, done.
for that. When it's in there, it's in one area of loss of sediment, falls there, but when time you move the jar, sifters and sifters, and how that jar, two variables.
So what Martin is saying is you're eliminating a whole step there. You just pull
Well,
the sifter out, shake it off, draw off the rocks and go.
No drying off.
And she said, how dry it off, so that you can
Yeah.
use the water.
right back.
And that-
But then you measure.
But then you're measuring water and rocks when you mask
Well, if
just
you
the
kept the
rock.
sifter in,
That's why we
sifter, it would not be.
So it wouldn't be a true mass of the rocks. if
Okay,
there was
let's
water.
go on, Tim.
You could use a cheesecloth.
You could use a cheesecloth.
And that way all your sediment and rock. Cheesecloth?
Good idea, turn on something.
It's just it's a piece of material real fine. And your rock and your sediment would all stay together.
Yeah.
You use cheesecloth in the aquifer lab, a piece of cloth that was
Yeah,
rubber
piece of
banded
cloth.
around the bottom when you poured.
Yeah.
Agatha?
Right at the grocery store.
With a bigger rock, and you can actually see the rounding of the rock.
Oh, okay.
If you use a bigger rock and they're not doing the trials. the
So you can
300.
see going from
You can see
angular
going from
rock to a more
around.
rounded, okay.
I was thinking when they were telling me about theirs, because we at one point poured some of our water back in the sifter to get it to drain fast. You know, when if you pour it faster, so maybe since they had a whole lot of sediment, can maybe have poured some of their jar back into the sifter, mixed it one more, try to get it in the jar, try to get more in the jar.
Jen, did you?
Well, yeah, I did, and I don't know if this actually it doesn't really have anything to do with conserving the mass. But I was thinking it might be interesting to take a look at the sediment under the microscope to see maybe even the roundedness of the
Oh, that would be
pieces.
fun, yeah.
So after every time you shake, you take a small sample and maybe get one of those blister slides, those little bubbles, so that they can see that the more you shake, the more sediment you should begin to see in each of the different samples. But then also maybe even to see the actual, what water does to the sediment and how it might, I don't know, even if you would even see any kind of rounding of the sediment.
Well, I think there, all you
If I
have
was
to do is
doing
get a rock tumbler and show a stone that you put in before and
Yeah,
a stone after.
and that's what I was thinking too. Just when you start your rock tumbler, really check on it, because it sometimes will cement the lid to the, so.
You sound like a most experienced.
That was a mistake that, check on it periodically often and loosen that lid.
Okay. Yeah, Agatha.
I think that this experiment touched on two objectives, because we saw that not only was it teaching weathering, erosion, and deposition, but the law of conservation of mass.
You're right, yeah. That's right, because in our system out in the world, mass is never created or destroyed. We might have some of it soaked up in a paper towel, but it's still there, we're just not able to measure it in our investigation. Okay, questions, guys? Yes,
Well, and also, that, I don't know where this, but our focus, if it's supposed to be on the water being the erosion, that maybe it could have just been without shaking it, because then all the other factors were taken into effect, and it wasn't just water showing the erosion. Unless you were trying to do all sorts of erosion types.
well, erosion is just the movement.
I mean, not erosion, weathering.
Weathering?
Yes.
So the water weathers, but it weathers chemically. So we don't have the time to measure the chemical erosion that water would, how it would affect the limestone. But what we were really measuring is how those rocks tumbling against each other, when you were shaking and swirling, how they knock chips off of each other and they sand each other down a little bit, so. But that's a good point. And I think Greg brought up earlier that we could add another variable and make, water slightly acidic. So it does weather the limestone, but not in a short time span. We could increase the acidity of, add vinegar or some more acid solution and see how that actually affects the weathering of the limestone.
Well, you could do it in two in 2 jars where you have,
Right.
where you can actually measure that.
Mm-hmm. That would be fine.
Oh, we had about 10 different experiments going on there.
Oh, you did?
Oh, yeah, we were coming up with them left and right.
Okay, my
Maybe
brain
take
hurts.
this, that.
Okay, Patty?
My only suggestion is I use this lab as a heavy review for controlling variables. It's an excellent lab. And so that's why I used the music, and everybody had to shake at the same time in exactly the same way to the same beat. And so everybody had a jar and everybody measured, and some shook. I dropped them off after 2 minutes, drop off the 4-minute shakers, drop off the 6-minute shakers, and then I had 8-minute shakers. So everybody started out with the same volume of water and same volume of rock, and then they poured it through the sifter, and collectively then we had class data. But extended it to the computer lab where all of the students who'd done the lab entered their data, and then you got that, what you would predict without doubt, curve. Is that what you wanted me to say?
Sure.
I'm just thinking, Patty's experiment is a great one for doing a beautiful curve, but is that realistic in reality? I mean, is that what's happening?
You mean how rocks
are
get
being
smaller?
measured? Yeah. I mean, is that beautiful curve over time?
Might be more elongated.
Yeah, I don't
I'm not sure that it is,
It
because you
probably
have
depends on the
different,
rock too. Well, you know, some rocks weather faster than other rocks.
but will also depend on, what kind of, weather patterns you have and seasons, and so I'm not sure it's that beautiful.
Yeah, I don't think I would term it beautiful. But I think you're right, that I don't think you'll see perfect curves like that out in the world.
No, because that's the math world. And the math world is always perfect, right?
Always perfect.
Always perfect. The science world
Beautiful.
is not,
Right.
right, gorgeous, pretty imperfect. But science is not.
It has beautiful functions,
Okay.
it always did. The
I have-
equations.
It's perfectly imperfect.
Excuse me, I have a question here for you. So we try to buy materials for you. I don't know how much these sieves are. You have a set of them. So I'm gonna look at a set because they have different size screens in them. And then, but these kinds of things, you can use anything that's heavy plastic, like mayonnaise jars or the, what'd you say, the high energy drink or
I use the
whatever.
Gatorade
As long as it
bottles.
has a mouth that would accommodate the size of your chips. So just think about the
Okay.
bottles that you're
Yeah.
going to use when you go out and find chips.
So we're not gonna buy these kinds of things for you that are, you know, grocery store kind of items, but we will look at these. And then Greg and I have been talking about something that you'll see after lunch, I guess. It's really cool. Okay, wait a minute, we have a question, but it has to be loud so everyone can hear.
Would you be able to use a soda bottle?
Most soda bottles that I experience nowadays are so
The
flimsy.
legs are small, too small to get your what's in
Yeah,
it.
funnel in the hole.
Yeah.
The
But I don't think so.
Gatorade bottles works
The
better
Gatorade
because the lids are bigger.
You know what, guys? Y'all are teachers. You know how to try out things and get kids to sample. You gotta practice before you experiment things. So, anyway, that's what we're looking at for you. And then one other thing, well, maybe, no, two other things. How many of you can come, what did we say, the 4th of? 7th of March? Look on your calendar.
Oh, I have Saturday school.
Oh, yeah.
I might have Saturday school, but I was with
How many, not in, well, yeah, it would be instead. How many of you can come on the 7th?
Of March, raise your hand high.
Inconvenient.
Saturday school.
6, 7. Wait, they haven't all looked at their calendars. 1, 2, 3, 7, 8, 9.
Better check. It might be a water cooler day.
11th?
Maybe.
11th,
They couldn't come.
No, 11 it could.
Okay.
11, and then what did we say? 9? Okay, and then the second thing is on your reflective prompts want to tell you the questions so you are to think about them.
Before you do that, we kept looking and looking on Google. It really is called Squiggle. Really is Squiggle. Yeah. Or scale
Or
break.
break.
Yeah, scale break.
Scale break.
So I've been talking about all these years.
That makes more sense. Scale break.
Yeah.
Okay, so there's two questions today. So the first one says, provide at least one example of how your growth as a teacher has affected student achievement in your classroom.
Oh, yes, I got that.
Say it again.
Provide at least one example of how your growth as a teacher from being in mixed has affected student achievement in your classroom. And it could be a range of things, you know, from your own personal tests or your benchmarks for the district or your star scores or what else?
Your enjoyment of your job, maybe?
Well, it's affecting your students' achievement.
Well, I think that if you're
Perhaps
passionate about what
the
you're doing, you're gonna.
But they want, how do you know your students have?
Measurable.
You could probably say the enjoyment
Attention
of your
span,
class.
attention span, my kids are more engaged.
Okay, so more engaged, all right, which could be for a number of reasons, including your passion.
Has it changed discipline?
Yeah,
I could,
I would definitely.
Okay, so it's those kind of things that you're thinking of. It's student achievement though, but that's not discipline. It's not that you can't mention it, but that's not student achievement. So they're looking for some kind of quantification of improvement of student achievement. So you can mention all these other things, which is good, but that's extra.
Can it go from hating math to really liking math now?
Student achievement, it should show up in student achievement.
Student hating math to liking math?
But it's going to show up in some kind of measure.
Are they doing their homework?
There you go. That's what I like.
But is doing their homework affect their student achievement? That's how you measure student achievement. Okay, guys, so you have the question. It's how, excuse me, it's how you could measure your student achievement has improved. Okay? Maybe what your principal thinks is measured, that counts, or the district that measures, or what you have measured. So it could be even, you know, within your own classroom. All right, so that's the first one. The second one says, how have the instructional strategies you've learned in teacher quality, which would mean this project, increased meaningful learning by all students in your classroom? So how have instructional strategies you've learned increased meaningful learning by all students in your classroom? Learning by all students in your classroom. Okay. So that's what you're thinking about, and I have to leave early today. I have a wedding of one of my former students at 3 in New Braunfels, so I have to go home, get Swindle, and then we go to New Braunfels. So you, about 3 o'clock, you're gonna need to stop, go into the lab to do your reflection. At lunch, Rowan's gonna distribute your book, what's it called? Stories in Stone. It's Jim's book. Stories in Stone, and also your meter stick. And then, Johnny, you've got your kit that you've never picked up, Investigating Groundwater.
Oh, okay.
Okay? All right? Okay. So you can go to lunch. You have 30 minutes.
Yeah, the third, yes.
I meant up at a sit down. Did you know what I meant?
Yes.
I knew what you meant.
See if I can still some good.
But I need this
Just because I'm wearing
Bring your lunch.
but I'm when I'm doing it, the snow.
Education Galaxy.
Water.
Right. Well, let me say two other things before we get to that. So what we would like for management to do is to use science examples, which is what you just said, use science equipment, materials, and to use the scientific vocabulary. So,
Mr. Craig.
So is this an
well, if you're using, sifter, then you call it sifter. You know, so you're going on the science equipment, you're gonna always, are you gonna already?
Having a party, yeah.
If you're a science teacher, we want you to use the that you normally would do, because in math, if you're a math teacher, you can just, stick to science all kind of places. In science, there are places that are already in our TEKS where we use the math. So we're not saying use extra math, it's already doing what you normally do with graphing and, data analysis, etc. But you would not teach math tricks. No math tricks. And you would not teach math, you would use the math vocabulary.
Well, yeah,
Okay.
which I use the math vocabulary.
Well, if you're a science teacher, you would use the math.
Oh, yeah.
Yeah, because here's what the normal day looks like. Normally, we would have, and we haven't had it today, because Browning is trying to let them get further in with the geology. But when we get into the dating, that she would teach some math, and I don't think it'll get to that point today. But normally, it's the geology and some math used, and the math is taught before we use it. So you want the math taught in a scope and sequence, so there's horizontal alignment. You don't want science trying to teach math, because we don't know it conceptually, and we're not going to teach it correctly. So you want the math taught by the math teacher first before it's used in the science. So
That's why
the
you
science,
want to
yes, and the science scope and sequence can be flexible. Math is not, it's pretty sequential. So you take the math scope and sequence, and then you fit the science in, how you can.
Yeah, because it doesn't matter if you go from light to
Well, and not only that, if you, for example, in 6th grade, they're calculating density, and it's pretty early in the math TEKS, and science TEKS. And so what we saw before the new math TEKS was that they were not getting it taught in math until November. So the science teacher is trying to have them calculate density in September, and they don't know how. So the kids end up being confused the rest of the year.
Well, and the multiplication skills alone.
Well, that's a different issue.
Yeah.
That's a different issue. So normally it's a science focus in the morning with math lessons in between, and I'm sorry you're not going to get Browning, because they love her. They call her the mathematician. And then for an hour in the afternoon, it's just pure math. And then you get 2 hours of lesson planning time.
To plan
your lessons, whatever you want to plan. That's why you want a partner.
So there's built-in planning time.
Yes.
Like true planning, not like you're being told what to plan. Because that's what I'm learning is a lot of the schools, they give you planning time, but they have something planned for you during that time.
No, this is free time. And we expect you to stay on task and be planning, not chit-chatting or gossiping or whatever.
You don't have a partner, let's say.
Well, you still plan.
Okay.
But the idea is you're.
But I could utilize the teachers
You
that
could,
are
like
here.
Tim is 8th grade math.
Yeah,
so
I could
you
utilize
could-
him.
yes,
What are they gonna
You
need
can sit
to-
in with another group.
Oh, okay.
Okay. But ideally, it would be better for you
Yeah.
to have a 7th grade math teacher that y'all are working together.
Well, yeah.
Yeah. Because your principal's already trained. He's been with us for 3 years.
Yes. I'm just wondering why he only invited me.
He invited another teacher, but they bailed.
Scott.
I do not know who it was.
Well, no, it was Scott. It was my teaching partner. Because what happened is we had Patterson, Busby, and me.
Mm-hmm.
Me being the newest first-year teacher, period, teaching a subject I don't know.
Right.
And then Patterson's been there 4 years. Well, she went on bed rest. Or Busby
Oh,
had
right.
cancer.
Yeah.
So, like, I have 2 people that moved in, and I'm kind of like running them.
Yes. Oh, there.
Which I had a good 5 months to prepare for, so, you know.
Or maybe he just thought you would be the kind of teacher who would like this kind of training. I don't know. Ask him.
I might.
Yeah.
Okay. But how, so for the observations, how does that work?
Okay, so we have, well, Greg goes out and does it. In math, it would be Browning, because she's she's really the math person, right? Now, others of us will go in classrooms, and for example, last month, Greg and I were together, and this teacher was giving students too much time. So there's kind of some generic stuff that we can see, okay, this is not working, you've got classroom management problems because you're giving them too much time or whatever. So we go in and we make an observation, we want lesson plans and all the handouts. And then we meet with you afterwards and we say, okay, what do you think worked well? And then we talk about what worked well and what you think didn't work well. And then we talk about, you know, how you could make it work better. And then, you know, what else do you need for us to do?
So it's not like a trouble thing, it's not like a,
Nobody knows
like,
about it. Mm-mm.
but that's what I mean, it's more like literally like helping
Mentoring.
as in, yeah, like
Right.
this, because
It's
that's
not a
what I'm
grade.
finding, like,
No.
I have like 2 periods that, I know there's some class member management issue, but I also think that a lot of that problem is I got hired Friday and started Monday in a subject I've never taught.
Sure.
Not even knowing what they were
Right.
teaching.
And it, you know, it might be that somebody comes in, I mean, I taught public school 18 years. Greg's
Yeah.
taught it about 25 and Macklemore's taught it about 25. So, you know, sometimes it's easy to go into a situation and it's easy to spot it.
So it's not like a graded thing, it's not like you can get
No.
kicked out of the program, it's like a,
No, no.
literally help, trying to
Mentoring.
help you
Right.
get better.
Twice
Well,
a
that's
month.
probably why, because that's something like I'm always asking him like,
Mhm.
what can I do to solve this problem?
Right. So
I will do what it is.
You're
What is
open
it?
to mentoring.
Oh, yeah, because, I mean, you all are like a wealth of knowledge. People that have been doing it a long time. And
Yeah.
some of the people in my school suck and they have no knowledge. Like, they're,
I know, I've seen them.
yeah. And I mean, maybe that's why too, because like I have very little use for some of the other people.
Well, I have little use for people who are lazy and who don't try to do the,
Well, like they'll
the
tell
best
me,
job they can.
they'll tell me all the time because like I'm there till usually 6:30.
Mm-hmm.
And they're like, Melissa, why don't you go home? Like, you're not getting paid for this. I'm like,
Do not tell me that someone stopped recording.
And